So, we are starting off. We ended up talking about how if x times y equals 0, then x or y, x is equal to 0 or y is equal to 0. Extrapolating that, if x, y, z equals 0, then x times x equals 0 or y equals 0 or z equals 0. And then we said if a function f of x equals 0 and f of x equaled x minus a times x minus b times x minus c times x minus d, then either x minus a equals 0, x minus b equals 0, x minus c equals 0, or x minus d equals 0. In order to solve for x, then, we simply had added a to both sides, and we got x equals a, followed by a similar process, x equals b, x equals c, or x equals d, and that completely catches us up to where we left off yesterday. So there's a quick little note that I believe I put in your notes that I wanted to add to that. So what we're going to be writing is the notes. If we have an exponent, if we have an exponent on a root, it's going to do something. Now, I don't know if there is a specific term for this, but these are my super non-mathy terms that I use. I call them bounce points and wiggle points. Bounce points and wiggle points. Richard Glosson, where are our notes? Okay. Bounce points or wiggle points. Bethany Wellinger, I hope none of those crumbs end up on my floor. No. No. You guys, my students, you guys never disappoint me. If ever you fail or do something, it's probably I've taken it on myself. It's I've failed you, and I'm disappointed in myself whenever you have failed. Okay. So we have bounce points and wiggle points. So if that looks like an onk instead of an F. It's from Egyptian, right? It's got the teardrop and then like the. So, all right. If a factor has an even exponent under notes, it bounces, the graph I should say, not it. We want some subject antecedent agreement. The graph bounces off the x-axis. At that fact or. Well then, before I get him a note. That was a good sneeze. And I won't say through. Off, I'll say through. Okay, so you guys can get that while I find a page of notes for Mr. Roberts. So I believe, if I'm not mistaken too, Bethany, when it comes to Oh What a Night, that is the first song that was when Frankie Valli and the Four Seasons brought in a new writer, and that writer was the same one who wrote and sang and performed Itty Bitty Teensy Weensy Little Polka Dot Bikini. Yes. He was the one that was a one-hit wonder, and after he couldn't get much further than that, he started writing for and performing with Frankie Valli and the Four Seasons. And when he heard Frankie Valli's voice and the fact that Frankie Valli was a big fan of brass bands and brass instruments, that's when he wrote Too Good to Be True, or Can't Take My Eyes Off You, whichever one it is, in order to bring that in. And that's when it was like kind of almost like a surprise when, you have that intro, that slow intro, and then finally it goes, everybody knows where it drops, and you bring in all those brass instruments. You know, you say that, but it's really just, you know, what is art, what is pretty, what sounds good. All those things are so subjective to our biology, you know, because our eyes are built to see the spectrums of light that we see. Diana Garcia Pineda? Under notes, yeah. Under notes. Both. Yep. Colin Roberts, I just can't seem to find an extra page of those notes. I had a bunch of them. I had a bunch. The chance exists, but I had so many. I found it, Colin Roberts. Now, Dimitri, what is legend foretold?
That he rose from the dead man after he died.
That Dimitri did? When did he die? But we don't need Chromebooks right now. To take home? Ask me after school, after class. All right. We got it written down? So what this means will become more clear, or will become clearer, I should say. Clear is a superlative. So, in other words, it can be ER'd or EST'd. Best, worst, better. Okay? So. Okay. All right, guys. What this means is if we look back at our front page of these notes, back at the front page, an x squared is a u. An x to the fourth is also a u. An x to the sixth is also a u. All these things, if there's nothing else modifying it, will look like a u. And so if we have an even factor an even exponent on a root, our factor, it will look like a u at that point. We'll kind of, and then the other ones will look like cubics. So this will all come together a little bit right now over me. Anyhow, so f of x equals 2x times. Okay. Now, really quick here, right underneath this, we're going to squeeze in something underneath that, right? So I'm going to have zeros located where? What equals 0, what equals 0, what equals 0? All right, actually, no, we'll put that somewhere else. What is my leading term? What would be my leading term? If this were all distributed out completely, it's going to be longer, but I just care. What would be my front term, my leading term? Stop it. You're so bad about it right now. 2x cubed. My leading term would be 2x times x, and then that would be multiplied by another x. Okay? So my leading term would end up being 2x cubed. Yes, that would be followed by something x squared, by something x, by just some number at the end of it all. No, it wouldn't. But still, my leading term is 2x cubed. That's important to me. Being able to look at it and determining what the leading term is important to me. So what's the degree on that? 3. How many zeros are there? 3. However many terms I have, however many of these factors I have is how many zeros I have. I have 3 zeros. Now, really quick, this is going to be kind of squeezed in this line. We'd have 2x equals 0. This is that x times y times z concept. 2x equals 0, x minus 2 equals 0, and x plus 4 equals 0. We'd have those 3 things. So if 2x equals 0, what would that give me? X is 0. X minus 2 equals 0. That would give me x equals 2. x plus 4 equals 0, that would give me x equals negative 4. So those are my 3 zeros. Yeah. Those would be my 3 zeros. I want you to write everything I have up there. Huh? Somebody said something? Kaya? Let's go. All right. Keep it on going. Is this positive or negative? It's positive. Is it odd or even? It's odd because it's cubed. Now, on these ones, I'm going to answer these in a second. Is there a bounce point? No. Is there a wiggle point? No. Give me 1 second. Do it again. All right, there you go. All right. We'll find out why in just a minute. So, earlier on my notes, when I told you guys to write notes, I said a bounce point occurs where a factor has an even exponent, and a wiggle point occurs where a factor has an odd exponent. And I didn't clarify on that. I did it third period. I just recalled right now. Riley, phone. I just recalled right now. But 1 doesn't count as an odd exponent on this one. I want odd exponents greater than 1. So 3, 5, 7, 9, all those ones. Okay? 1 does not count when I'm talking about odd exponents. So is there a squared on this x? Is there a cubed? Is there anything on that? No. So it's just a 1. Is there a squared or anything on this parentheses? No. Is there anything on this one? No. So there are no bounce or wiggle points because of that.
So if there was a number on either,
There would be something. There would either be a bounce or a wiggle. Okay?
can you explain that again?
You'll see it in the next examples. So I'm just saying that if you don't see an exponent on any of these factors, it's just going through. Elias?
If you were to put a 3 on the parentheses of x minus 2.
I'm not doing what-if scenarios. Those come in other examples. Okay? All right. So really quick, I'm going to go. So first of all, this is a degree 3, so it's a positive odd. It is a positive odd, which means it starts low, ends high. We good? Then I'm going to pass through 0, 2, and negative 4. So if I were to say my graph has to start low, end high, it's got to pass through those points, there's only one way my graph can look, right? And that's going to be go through that, down there, through that, up there. Okay? No, I can't. I already finished the graph. Sione? You okay?
Is that negative 4?
Yep. That came from my 0.
So how do you know that you did that?
What do you mean? So since it's odd and positive, I start low, end high. I have to cross through 0, 2, and negative 4, and I have to connect all my dots. So in order to do that,
Start low and high.
because it's a positive odd,
Because it's a positive odd. Okay.
okay? How do we feel about that? Now, the only thing I don't know for sure, I'm going to erase my line right now. For all I know, it could have looked like this. Could have been that. Oh. Could have been that. I don't know. We're not too finding out whether or not where exactly it crosses at. So for now, we just do our best estimate. And we make it pass through those points. All right. We're going to do the next one. Somebody, f of x. Do you add a squared at the end of that? Okay. I thought you said something after you said x minus 2. All righty. My leading term. So first of all, my leading term. Let's put that away, sir. How many x's are here? 2, right? 2 of them are right here because x squared. Okay? 2 of them are right there. How many are right here? 1. So we have how many total? 3. So this is going to be x cubed. And what's in front of it? A negative. So my leading term is negative x cubed. I need everybody to be able to do that. Just kind of mentally look at it and say, there's an x squared, there's an x squared times x makes x cubed, and there's a negative out front. What's my degree? 3. You said you don't have a negative degree, no.
If there wasn't a square, would it just be
2. Because there'd be an x there and an x there, so it'd be x squared, negative x squared.
so would it be 4? Would it be 2, 3, 4?
Hmm?
It wouldn't be 2, 3, 4.
Why are you saying 3 numbers?
I don't know. I'm trying to say because I was thinking there'd be the 2, so that's.
So if that's x to the 7th. That's x to the 11th.
Oh, so we pretend there's a 1. 1 there.
That's x to the 18th.
I got it.
All right.
I think it's
All right. Yes, we pretend there's a 1 right here. Boop.
that's exact. See, I was like, what do we add? Do we add all the x's?
All righty. Now here, guys, how many zeros? Michael, Seth, let's focus. It's not braiding time. Yes? No, Elias is correct. 2. Okay, there are 2 zeros. Okay? X plus 1 equals 0, and x minus 2 equals 0. So this one gives me x equals. No, it doesn't x equals Mr. Bates. That's weird. X equals negative 1, and x equals. And now Sione had a question. Huh? So we're finding x. We're finding where it crosses the x-axis. So if we're finding where it crosses the x-axis, we're pretending that this is 0, and when it equals 0, we set each item equal to 0. That is why. Okay. Is it positive or negative? Negative. Is it odd or even? Odd. Degree 3. Okay. Is there a bounce point? Yes. Is there a wiggle point? No.
Oh, I was right. How do you know?
Okay, bounce points. If any of my factors have an even exponent, dun dun dun. If any of my factors have an even exponent, there is a bounce point. If any of my factors have an odd exponent that is not 1, there's a wiggle point. Okay? Kaylee, we don't have a phone or anything, do we? Okay. All right. Seth, we need to clean up our own house before we talk about others. Okay. I know, but if I see students looking down in their lap, I ask. It's weird. Okay. All right. All right, guys. So I have a 0 at -1, and I have a 0 at +2. So I'm going to be drawing some arrows here in a second. And it's an odd It's a negative odd, so it starts high, ends low. So let this digest.
I think I get it.
Digest. No S. Okay.
So it could be a bunch of different things, but as long as it goes, it's fine.
All right. Well, almost. It's got to also hit those points.
Could it go?
So if it was a positive even, it would have started low and high.
If it was a positive even, it would start high, end high.
That is not what it's supposed to be.
Positive even, starts high, ends high. Even, positive. Okay. All right, now here's the thing. Here's the important part. We have a bounce point. Michael? We have a bounce point. So if we try to do the same concept as before, I'm going to start high, end low, and I'm going to pass through these points so I connect the dots. What would happen is you guys would be like, okay, boo, because I need to get down to that arrow. What do I do?
You make the line go lower into where like the curve would be through the dots, right?
Okay, so make the line go lower. Then go down? But did I cross another time? No, I only have 2 zeros.
Wouldn't you just make it along the x-axis?
So what happens is, on the one that has the even exponent, at -1, I bounce. I don't pass through. I bounce off of it, come back up, come down. Yeah. That's what you said? Okay.
I still can't.
Holly,
Yes.
what's up?
I'm very bad at drawing.
Oh, it's okay. I mean, mine's free-handed, so just try to make it, I mean, like that or better is good.
So wait, why does it only bounce on the -1?
Because the -1's the one that has an even exponent on it. So what it's saying here, I'll wait actually till we're done trying to draw. You can. I believe in you. I don't believe that Holly Ross is a mythical figure. There'd be something. There has to be something. Okay. Then it would be an even function or something. Alrighty. What's going on, guys? What's going on is each of these had an exponent of 1. Are we okay with that? So where it passes through, if I zoomed in, I don't know how much I could zoom in.
Oh, that's perfect.
Why is it like that?
It's still not big enough for you to see.
You're going to the whole screen flat.
It is. I missed a little bit. But, okay. But at some point, guys, we've zoomed in enough. If this were solid, like, and I'll actually, you know what? Maybe Desmos would have been the easier thing to use. Go to Desmos.
Is this like the psychiatric drawings that you have to interpret in your brain?
And this is what you guys spend your time, right? This is how you spend your time. I want you to understand that when you think about, like, I don't want to spend that long learning math or doing English or whatever it is. I had kids 4th period today, and I'm sorry, Lord, for even showing them this, because some of you are now going to do this at some point. I'm looking at you, Seth. Okay, so some of my 4th period students, they had out their stopwatch. Let me find it here. They had out their stopwatch, and they had it on that, and they were seeing how fast they could stop, and to get it as low as possible. And that's what they were doing. So I got 0.13, and they're like 0.13 again, and 0.12. They're like, oh, you got lower, and they were like, no, Mr. Bates, you got to put it on a flat surface, and you got a 2-finger. And I'm like, this is how you spend it? And he's like, Mr. Bates, I did it for like a half an hour last night. Half an hour. Half an hour. And what's sad is every single one of you can picture yourselves doing that. You can't picture yourself learning for 30 minutes, for Christ's sake, but trying to get point oh, his fastest time, if you guys want to try to beat it, his fastest time is a .06, I think. Or a point, or .0, it might have been, you know, it was a .04. No, you're not going to do it right now. So I didn't try it. I did exactly what I showed to mock them, and then I'm done because I'm not going to waste my time doing that. So, anyhow, I'm just saying, you guys like zoom it in until the screen's black. Like if it took me 18 to 20 more times pushing zoom in, you guys would have waited for it. And you still would have been surprised when it finally went all black and been like, oh! You know, you can see exactly what's happening. I don't understand. No. Okay. So. Huh? Raymond? I'm going to have to write you up for defiance because I said, no, you're not doing that right now, and then you just decided to do it. But it's all right because Michael's literally doing it right this second. So which one's worse? All right, f of x equals, what was that last one we did, folks? Plus 1? Okay. Oh, I put a subscript there. Boop. Okay. So there it is. Oh. Boop. Okay. So, what's going on? What's going on? What I want you guys to understand, so the even one. What the even is saying, when you have an even exponent on a factor, is it's saying when I zoom into that point, the -1, what's it look like? A parabola. Because a squared function is a parabola. So it's making a parabola at x plus 1 squared, which is a parabola shifted 1 to the left.
I'm not going to say the bad word, but what did you just do? Can you read that?
So I had this. I just zoomed in on that factor, which was the squared one, and I'm showing you the bounce point. Okay? And then now the other one, x minus 2, doesn't have an exponent. So if I were to zoom in here, if people didn't know any better, what does that look like? It looks like a line. And something to one exponent of 1, looks like a line. Yes? My day has been going well, thank you. Okay? All right. What? Oh no, I'm quite all right. I believe in myself. I actually get really annoyed when certain things that like positive reinforcements. I get annoyed at most people when they say things like that to me. At the beginning of every month, the district puts like candy bars in all the teachers, so and it's got like some phrase like, "Hey, we appreciate you," and it just ticks me off. So. Anyhow. Okay. Oh, the candy bar's good, but I don't. I appreciate. I don't mind being appreciated. I do like that, but I like it to be personal. Yes. All right. What's the last function? Okay. All right. Ladies. Weirdness. What? 4. Okay. Leading term is x to the 4th. Shh. Ladies, come on. Leading term is x to the 4th because x cubed times x is x to the 4th. Is it, what's the degree? 4. These are not necessarily true. How many zeros are there? 2. We have x plus 2 equals 0 and x minus 1 equals 0. So x is -2 or x is 1. Is it positive or negative? Even or odd? Even to the 4th power. Is there a bounce point? Is there a wiggle point? All right. Where's the wiggle point at? Not at 3. The 3 is what's causing it.
Okay, that's what I meant.
It's at -2. So the 3 is attached to the +2, which means it's at the -2, so that's our wiggle point. And I say wiggle point, but we'll see what we're talking about in a second. Now, once again, quote-unquote wiggle points are interesting because we have to know which way it wiggles. Is it going to wiggle like that, or is it going to wiggle like that? Yes, sir. How do I know what? So its degree is, so positive is this leading coefficient. Is it a plus or a minus in front of it? So since there's nothing in front, it's positive. And then the even is what is the exponent, even or odd? Okay. All right, so I go through -2 and I go through +1. It is a positive even, so it starts high, ends high. Starts high, ends high. Okay? So I'm not bouncing off of anything, but I have to wiggle my way through -2. So because of the fact I'm coming into -2 from the left, it's going to wiggle like that through it. So what's going on? I'm okay with that.
No, not your drawing. Just
Okay. Yep. It just wiggled really quick right through that point.
I don't like it. I have a thing with like straight lines.
Well.
Why don't you just draw a rest of it?
Now, what's important here? I'll bring this one up on Desmos in just a few seconds. What's important about here is if I were to zoom in, or maybe you guys can think about it, if I zoomed in on this point, I'm not going to zoom in. It's going to look like what? A cubic.
A negative.
It looks like it does look like a negative cubic. It does look like a negative cubic right there. So I passed through -2 like a negative cubic would.
And then it's a.
Now we have to be careful. We have to be careful because if I change this problem just a little bit, it's not so the fact that it's a negative cubic you can't tell that until you draw it. You can't tell until you draw it. Because if the 3 was on the x minus 1, it would have passed through here all right and then had to wiggle through that. And then it would have looked like that instead if the 3 was on the cube was on the +1 instead.
Wait, why is the wiggle point on -2?
Because -2 is the one that had the cube on it. Yes?
Did you say like there's a way to determine like which way it wiggles?
You have, yeah, so what happens is, because I've had students in the past, so I'm going to just go to another page. Okay? I've had students in the past who maybe the function looked like this. X minus 4 cubed times x plus 5 squared times x minus 1. Okay? So if I have this, first of all, what's the degree on it, Cameron? 6, and it's positive, right? Okay, so everybody okay? This is a positive even? Starts high, ends high, positive even, and it's just x to the 6th. So I'm going to bounce off of 4. 1, 2, 3, 4. I'm going to wiggle through bounce off of -5. 1, 2, 3, 4, 5. I'm going to bounce off -5. I'm going to wiggle through 4, and I'm just going to cross naturally through 1. We okay with that? So I've had students in the past who like try to, and then I'm like, I start high and I end high. So they have all that down, and they know the bounces and the wiggles. But what they do is they stop and they're like, okay, so I'm wiggling through 4, and they make an assumption about which way it does it. And then they're like, and I'm going to bounce off of -5. But then when you try to go connect the dots, you're like, oh, whoops, no, what? You know, so if you make assumptions on which way it goes, you might end up kind of causing yourself more annoyance, right? So you have to look at, so I'm coming from the left to this dot, and that needs to be my bounce. And then I need to pass through that, so I need to go through like that. Don't make any assumptions. And so since I'm approaching from the bottom left, if my wiggle went like that, it's not going to go back and then out, right? So don't make assumptions about the direction. So since I'm approaching it from the bottom left, I need to go through it like that. Yeah, when you're approaching it, which way does the line come through? And it's just really easy to get a graph. So if I were to, like, there's my super quick sketch of this. Once again, I don't know how high that goes or how low that goes, but if I were to put this into Desmos, nope. Keep on holding that shift key too early. There we go. What did I say? X what? Plus 4 squared? All right? And then x minus 1 was in there, and then x minus 5 cubed, right? Oh, minus 4 cubed. Minus 4 cubed plus 5 minus 4. Oh. Minus 4 cubed plus 5. Doesn't matter which one, the order. Order doesn't matter. Oh. There we go. Yep. Minus 4 cubed plus 5 squared minus 1. Yep. So what I don't realize, right? So let me actually change this, because mine's a quick sketch. So I'm going to have to do my x-axis. I'm going to go from -6 to 6. And I'm going to do my y-axis really huge. I'm going to go from -10 to 100. 1,000. 1 million. Now I'll go to -50. -100. 1,000. There it is. Okay. So this actually, the peak of my maximum was a little over 6,000, as opposed to what I thought it might have been. I guessed like 2. And then this bottom peak I put at -2, and in reality, it was at -500-ish. But I still bounced off -5, passed through 1, and then wiggled through 4, which is what my graph. No. For this lesson, intents and purposes, how high you make it doesn't matter. Okay. But really zooming out in a very specific way. Right, Natalia? Okay. 4. You guys, you're going to have to do your homework tonight. I'm going to give you guys 5 minutes to do the first couple, only 5 minutes. Then we're on the workbook. Do 1, 2, 3, 6, 7. 5 minutes to do 1, 2, 3, 6, 7, and then I'm going to do 4 and 5 with you. 4 and 5 are super easy, but you have to pull in the concepts. Do 1, 2, 3, 6, 7. I'll do 4 and 5 with you in 5 minutes. Yep. Sorry. So it turned twice, so it looks like this. It turns twice. This is a local maximum. Why is it local? Because there are points higher than that. There are points higher, other points. That's why it's a local max. And therefore, there's also one local minimum right there. Because there are other points lower than that on the graph. Yeah, time-wise, I'm moving on to number 5 again. Okay, This is a negative even. X squared times x makes x cubed times x makes x to the fourth. So this is a negative even. It has to bounce, so I'm starting low. I'm going to pass through negative 1, bounce off 0, then go through 2. So I've got to pass through 1 0, bounce off another 0, and then pass through a third 0. How many times does it turn? 3. Okay? 2 local maximums. Or sorry, 1 local max, 1 global max. 1 local max, 1 global max. Why? Because one of these two is going to be higher than the other. One of those two is going to be higher than the other, so it's the global max. The other one's a local max. And then this minimum, there are plenty of points lower than it, so 1 local minimum. Hopefully the other ones were pretty easy for you. When it says x-intercepts and zeros are the same. They're what I refer to as zeros. Okay? No, actually put what they are.